type that had, I called it type 3, and it had both an absolute value with an inequality. I believe I probably just did one at the end, so we'll do a few more. So, example. Oh, it's a bit bright. Okay, so you look at the question and you say, okay, that's got an inequality and an absolute value. Absolute value always means you have two cases you have to look at. So you have two cases to write out because it has the absolute value. What I do is I go off to the side. Okay, so the cases are -5 and 5. Now, being less than, where is it? It's either on the outsides of that or in between. So it's less than 5, so it's in between. It has to be numbers that are closer to 0. So we're looking at this section. Equals 5 or not? Equal. Okay, so when we get our answer, we're going to color in those dots and we're going to put our new number line. Okay, because this would be if it was just x in there. Okay, so now we say the same thing. So here, this would be that whatever it is we're solving for has to be between 5 and -5. So that's how we're going to rewrite it. So we're going to say that x squared minus 4x has to be between, the lower number always goes first, 5 and -5. And then to solve this, if you remember, we split it into 2 with an and, because we want it to be in between them both larger than -5 and smaller than 5 at the same time. So we'll rewrite this as two equations. All right, and that's the whole start of the ones with the absolute value. You've got your two cases now. We back up to type 2, which was inequalities, no absolute value, and we just solve. So we're going to solve the 2. And the technique for solving quadratic inequalities is to change the sign to an equal sign and then solve the quadratic. So we'll say that x squared minus 4x plus 5. And then you say, does that factor? It looks promising, but I don't think it factors. Right? What multiplies to give 5? 5 and 1? There are only options. Can for a plus, they have to add to give 4, and they add to give 6 or -6, so that won't work. So what do we do? Quadratic. So minus b minus the -4 is plus 4. B squared minus 4 squared is plus 16. All over 2a. So 16 minus 20. So what does that mean? No solution. So this part didn't give us any information. Okay, we can't have a negative under the square root. This is the square root of -4, so there's no solution to this part. Okay, so it just gave us no information. So then we go over and we solve our second case. Same idea, set it equal to 5. Now this one does factor. If we have a -5 and a plus, because of that minus sign, we want to subtract to get 4, and 5 minus 1 is 4, so that will work. So x plus 1 equals 0 gives me -1, and x minus 5 equals 0 gives me 5. Okay, so we've got two numbers, and we're using those numbers not to solve this inequality. Right? What we found is the possible roots, or the possible switching numbers where it switches, for this question. This is our original question up here. Okay, so what do we do with them? We put them on a number line and we test them into the original and see what works. So we put these on a number line. And test in the original question. And what are we testing? Make sure you put them in the right order on the number line. People do that, mess that up. So what are we testing? Are we testing minus 1 and 5? No, that's what will make it equal 5. Right? We actually want to find where it's less than 5. So we want to plug in the numbers in the intervals. So there's 3 possible intervals. This is x is less than -1, between -1 and 5, and greater than 5. We want to test those 3 intervals. So we need to pick a test point in each region, plug it into the very original question, whichever ones work. So our first test point, what do we want for something less than -1? -2, -10. Let's go -10. Between -1 and 5, 1, 2, 3, 0, 0. And bigger than 5, let's say 10. Okay? So if we test -10 into the original question, let me just write the original question, it's off the board. Okay, so here it is. Plugging -10 in. -10 squared. Make sure you have the absolute value brackets. That's in the original question. Minus 4 times -10. Let's just work this out and then see if it's less than 5. So we have 100 minus 4 times -10 plus 40. The absolute value of 140 is 140. So does that work? Is 140 less than 5? So I would go right up, back up and cross that off, just so I don't make no mistake that that's part of the answer. Okay. Next one. 0. 0 squared minus 4 times 0. 0 minus 0. Absolute value of 0. Is 0 less than 5? And positive 10. So 100 minus 40 is 60, and absolute value of 60 is 60. Is that less than 5? No. Okay, so you've tested each region, figured out where it worked. The numbers themselves are if it's equal, and we can write our solution. Now on the test, for this question, I said to draw a number line. What I don't want you to do is this number line that you use to test, draw a new one. Don't circle that as your answer. I don't want to see that. I want to see a new number line with the solution shown on it properly with either empty circles or colored in circles. Okay? So for our solution, we want the numbers between -1 and 5. So solution, -1 to 5. Do we want equal signs? So it depends. If the original question has equals, then yes, and it does. And a number line to illustrate that. So -1 and 5, both colored in because we want them. And there's no arrows on this because we're in between two numbers. Okay, so this would be your solution. Questions? So it's a bit long, but what you do is first you identify the type. You say it has an absolute value and an inequality. Any absolute value question has two cases. The inequality is the one that makes it either in between or on the outside. So let's do another one. So we'll do a greater than instead of a less than. So again, you say absolute value, that's two cases. We need to look at both the plus 6 and the minus 6. Now we want greater, so that has to be beyond or farther than 6, so, and not equal, so we're looking over here and here. That's our two cases. And when it's not in between, you do have to start by writing it as two cases. So we're going to say when whatever it is less than negative 6, and then when it's greater than 6. So we've got x squared minus 5x. We want it to be less than negative 6. And or, because they're not overlapping, or x squared minus 5x is greater than positive 6. And now it's back to type 2. We have no absolute value. We solve each of these equations. And to solve them, you put an equal sign. Move everything to the other side. Factor if it factors. Does this factor? Yes. Two numbers that multiply to give 6 and add to give 5. 3 and 2. We want them both negative. So x equals 3, x equals 2. So there's 2. Second side. Change the sign to an equals. Does this factor? Two numbers that multiply to give 6 and subtract to give 5. 1 and 6, it does work. If we want them to subtract to give a negative 5, the 6 has to be negative. So x is negative 1 and x is 6. So we've got 4 numbers this time. So what does that mean about our number line that we're testing? There's 4 numbers, so there's 5 intervals. Okay, so we have a lot of testing. And where do we test this? Which equation? Always right back in the start. So, let's see, a number less than negative 1, say 0? Or, sorry, no. That would be wrong. Negative 10? Between negative 1 and 2? 1, 0. Between 2 and 3. And then you say, oh, yeah, 1.5. As a fraction, you can put 1.5, but remember, you have no calculator. Yeah, someone said it. How do you get a fraction? 3 over 2? You want 3 halves, right? 1.5 is 3 halves. That's 3 over 2. I'm going to do that. You can plug your 1.5 in and do your long multiplication if you... Oh! Geez, I'm on a roll. 5 over 2. 2.5, right? Yeah. Yeah, so what happens if I do plug in the wrong thing? What's going to happen? Say I wrote that and none of you corrected me. You're always good at correcting me, so that's good. But what if I didn't? So on a test, you might do that, right? What would happen? I've actually tested, where is 3 over 2? In here? Then I tested 2 in that region, and I would have, like, scratched that, right, so I wouldn't have the right answer. It's okay to test more than 1 in a region, but not necessary. Between 3 and 6? 5, sure. And maybe 10. So 1, 2, 3, 4, 5, we have to test. All right, so let's plug them in sort of quickly. We're going to plug these into the original, and the original is absolute value of x squared minus 5x is greater than 6. So we're going to plug it in, and then we're going to look down the list and see which ones are bigger than 6. Does that make sense? So minus 10 squared minus 5 times minus 10. So that's 100 plus 50. 0. 5 over 2. So this is the one you want to see. So 5 over 2 squared minus 5 times 5 over 2. So how do we square a fraction? This is from way back. Square the top, square the bottom. So 25 over 4. What about this one? That's like a 5 over 1. So 5 times 5 is 25 over 2. Common denominator? 4 times by 2, yeah. All right, minus 25 over 4 in the absolute value, which gives us positive 25 over 4. How many times does 4 go into 25? So 24 would be 6 and 1/4 left. And remember, I don't like this, but I said that we don't write our fractions in mixed numbers. We leave them. And I said the only time we use mixed numbers is when you're trying to see if it's bigger or smaller than something. So you would convert it to a mixed number. Now we know that that 6 1/4 is bigger than 6, right? And the other place for this, and I said it earlier too when I told you never use mixed numbers, is in graphing, because the same thing. If you had to plot that point, you would want to know, oh, okay, it's 6 1/4, so we go a little bit above 6. Does that make sense? But why, do you remember why I said we don't use mixed numbers? Other than that, to see where a number would fit between? It's stuff like this. I'll just write a little note over here. If you had 6 1/4 and you wanted to times that by x, where does the x go? Is it with the quarter? Is it with the 6? Is it on top? Is it on bottom? Do you see that it looks a bit confusing? Whereas if I had 25 over 4 times x, this is 25x over 4. You see, it's a little bit strange to see it this way. Yeah. So in calculus, we don't want to use mixed numbers unless we're trying to plot a point and we need to know where it falls in between. Okay, 5 over 2, the next one is 5. So 5 squared minus 5 times 5 is 0. 25 minus 25. And our last one, 10. 10 squared minus 5 times 10 is 100 minus 50 and 50. Okay. So I didn't look and cross them off as I went. I had lots of numbers, so I said I'm just going to figure them all out, and then I'm going to look back and say, what do I want? I want anything that's greater than 6. So which ones are greater than 6? This first one. 0? No. 0 is not bigger than 6. 6 1/4? Yep. 0. And 50? Okay. So how many regions are in our final solution? 3. So we write those 3. So this first one, let's just draw our new number line first. So negative 1, 2, 3, 6. Now, there's a good reason why I put all of my test points in a circle above the line, is so you don't accidentally, when you rewrite it, use them on the number line. Do you see that I did that? And I keep doing that every time because I want to make sure that when I draw a number line, I am still using the numbers that I'm supposed to have on the number line, not my test points that I chose. Okay, so is there an equal sign in the original question? No. So we want an empty circle. We want this one. We want the one between 2 and 3. and greater than 6. So we draw a new number line for our solution. Here we would say x is less than -1, between 2 and 3, and greater than 6. Conclusion to this, it's better when one side of this doesn't work. You only get 2 numbers. It's a lot less work. It's actually easier to write a question that only one side works. It's harder to find one that will give us 4 numbers. The other bad thing about this is if you have to use the quadratic equation to get an answer, then you've got like something 1 plus root 11, and you need to pick a test point on either side of that, which is totally legitimate, because when we did radicals earlier, I told you how to guess what they're equal to. What would root 11 be close to? It's a square root game, remember? Square root of 11. You're too slow. Square root of 11. 3.2. You're right, whatever. Right? As long as you get between the right numbers, you're right in the square root game. So how do you know it's 3.2 for the people that didn't, or 3 point something? Right? We're saying square root of 11. If you had to guess what that's equal to, well, you know the square root of 9 is 3, and what's the next one? 16 that we know. Which is it closer to? 3. So you could say anything. 3.1, 3.2, 3.3. It doesn't matter. What you're trying to do when you estimate, just like we did with the fraction, is get in between the right numbers. Right? If you had to pick a number bigger than that, you could easily pick 4. Or a number smaller, you would be safe to say 3 is smaller. Right? If you had to pick a test point on either side. So that's a legitimate question, that it actually doesn't work out nice and you have a square root in your answer and you have to pick test points on either side. Okay, so what I want you to do is, this is an absolute value, put that little number line over to the side with the 10 and the -10 on it. Put your number line off to the side with the 10 and the -10 and shade which parts we want in this particular question. Who's confident so far? There, you got a half a mark. All right, so where is it? Less than 10. Between. And how do we write anything in between? Your inequalities always point down. The smaller number's always first, the bigger number's always second, no other option. Okay, so instead of x, what do we have? X squared plus 3. So now we come over here and we say, okay, x squared plus 3 has to be between -10 and 10. Now, because that's an inequality with 2 signs in the same one, we have to split it up to solve it. So we split it up, -10 less than x squared plus 3, and x squared plus 3 less than or equal to +10, or and because it's only one region, we want them both to work. Next, change signs to equal. And solve. Oh, good. Why good? Sum of squares, no solution, that's not going to give us lots of numbers. So no solution here, sum of squares. The second one, set it equal. Move everything to one side. Difference of squares? Yeah, so this factors x square root of 7 1 plus 1 minus. X plus root 7 gives us x is minus root 7, and x minus root 7 gives x is plus root 7. Yep.
So in the next step, would the minus root 7 just not work? Since you're trying to get a negative numerical.
No, minus is outside of the square root, right? So a minus in front of the square root's okay, a minus can't be under the square root, right? So this, yeah. So both of these are okay. And we would put them on a number line, minus root 7 and plus root 7, and this is exactly what I was saying. We need to pick a test point in each region. So it would be good to know what these numbers are between. Right? So what's root 7 in between? It's in between root 4 and root 9, 2 that we know. It's in between 2 and 3. And what about here? So this would be, it's 3 away from this and 2 away, so what's going to be your guess? 2 point, sure, 2.6, 2.7, a little bigger than a half, right? So it doesn't really matter because we're not using that number. We just need to know what's on either side. And what would this one be then? Negative 2.6. Okay, so a number in between these, 0. A number bigger? Well, 3 is bigger, but you could go much bigger and say 10. And you could say negative 3 over on this side, or say negative 10. And then we're going to check them back into the original. Our original equation, x squared plus 3 is absolute value is less than or equal to 10. So we're going to find our numbers and see which one's less than 10. Make sure you put the absolute value. This is 100 plus 3, 103. This is 0 squared plus 3, 3. And this one's the same as the first one, 100 plus 3, 103. We want the ones less than 10. The middle? So these two don't work, we want the center. And so our solution, a new number line, don't put your guess on here, like your approximation, put the actual number, so put the root on, don't put 2.6 or whatever you guessed it was, okay? This is more accurate. And we want the ones in between. Do we want equal sign or no? Did the original question have an equals? Yes, so color those in. There we go. Okay, so the numbers don't always have to work nice. You might have to use quadratic equation or something, but all you do is guess where it is, and then you can still pick a number bigger and smaller. Or estimate it. Okay, ready for your trick questions? And I'm saying it's a trick, so that means you have to sort of think about it. Who has some thoughts about this one? What's that? Another thought? What's that? All real numbers? Yeah. It's an absolute value, which means it's a distance, which means it's always positive. And what am I asking? Where it's positive. So what would be your solution without doing any work? All real numbers. Okay. What about this one? Okay, I'm still saying positive. I'm still saying greater than 0. But I'm not saying equal. So what are your thoughts on this one? So there's lots of numbers that work, that make it positive, and there might be some that make it equal 0, and we don't want those, because we don't want it to equal 0. Okay, so here, if you were just to start this in your normal way, you can't say minus 0 and 0, and we want on the outside. That doesn't make sense, right? So don't do that. Right? So I called it a trick because it doesn't follow sort of the recipe that I gave you for these questions. You have to think about it. Absolute value always has those sort of tricks, the equals 0 and equals negative, because that's not possible. Right? So here, this one, any number I plug in here will work. So the solution is all real numbers. All real numbers work except anything that makes it equal 0. So what would that be? Factor it. Common factor. This gives us 0 and negative 4. Don't forget this one. So these numbers, when you plug them in, 0 squared plus 4 times 0, that gives us a 0, and we don't want it to equal 0. And the negative 4, that'll be 16 minus 16, also 0. We don't want those. So our solution for the second one, we would say, is that x cannot equal 0 or minus 4, semicolon, x is an element of real numbers, meaning it can be anything else. Whereas the first one, we don't have that restriction. So what if I said x squared plus 4x absolute value is less than 0? What if I said less than 0? Can an absolute value be less than 0? No, so what would we say? No solution. Right away, nothing to do, no solution. Now what if I put less than or equal to? It can't be less than 0, but it could be equal to 0. Right? Where does this equal 0? So x can equal 0 or minus 4. Nothing else. Does that make sense? So this one, it can't be less. Why not? All right, one more trick. Not really tricks, but oh, no, that's not what I meant to say. So remember, an absolute value can't equal negative. It's positive only, or 0, right? So here I'm saying greater than -4. Can it be greater than -4? Well, it can't equal -4 because it can't be a negative. It can't equal -3 or anything in between those. It can't equal -2. It can't equal -1. Is there some solutions that work? What is this the same as asking? How else could I ask this question and the solutions would be the same? So, without looking at the absolute value or anything, this is what I'm saying. I want it to be greater than -4, but an absolute value can only start at 0. So here's 0. So really, it can't be here. It could be 0, which is greater than -4. So it's the same as asking what? Absolute value of x squared plus 4x is greater than or equal to 0, which is all real numbers. Nothing to solve. It's all real numbers. Anything you plug in will be the absolute value of that number, which is positive. Right? Where in contrast, if I said the absolute value of x squared plus 4x is equal to -4, what would we say? No solution, because it can't equal -4. It could be bigger than -4. Anything that makes it bigger than 0, which is all real numbers. So this answer is all real numbers. This one is no solution. Right? Just to confuse you.